are these shortcuts, okay, in triangles. So say you have two triangles. I'm going to try to draw. Am I in the way?
Yeah.
Okay. I'll move to back here. Now am I in the way? That's better, right? So, say I have a triangle. Where's my triangle drawing tool? Is this a triangle drawing tool? Sure, why not? I have a triangle that looks kind of like this. Ooh, that's good. And what I know about this triangle is that this angle is 50 degrees. And this angle is 40 degrees. And 50, 40, and that then I have another triangle. And what I know in this triangle is, where's my other triangle? Let's draw another triangle. I can do that. Does that look like a triangle? Sort of. And I'm going to tell you that, all I'm going to tell you is that this is a right angle over here. And then this angle here is where, let's say that this angle here is 40 degrees. Okay? And I will say, are these triangles similar? Are these triangles similar? What do you think?
Yes.
Okay? Yes, the answer is. Why? Okay? Because what does this angle have to be right here?
90.
This would have to be 90 because 50 plus 40 is 90. And we realize that these have to add up to 180, right? And so if this is 40, what does this have to be? 50, okay? And so that's kind of, it's conjecture C93, okay? Which says that if, and for triangles, if the angles are the same, only for triangles, if the angles are the same, then you don't have to worry about the sides being proportional as well, okay? Because the sides automatically are proportional in a triangle, okay? So if these angles are all the same. So all you have to worry about is if you know that two angles of one triangle are congruent to two angles of another triangle, then those triangles are similar. So the answer to that is yes. And then I say I know that this side is 8, even though this won't be to scale. And this side over here is 12. 12. Let's try this one more time. 12. And I know that this side over here is 10. And I say find this side over here. Find x. Find y. Could you do that? It's a little bit tricky because you have to figure out which goes with which. Okay? So 12 goes with what?
X.
12 goes with x, right? Because those are both the hypotenuse of those triangles. Hypotenuse. 12 goes with x. As 8 goes with?
Y.
8 goes with y or 8 goes with 10?
Oh, 10.
As 8 goes with 10, okay? And I know that because this side that is 8 is in between the 40 degree and the 90 degree angle, okay? So you have to look for the other side that is in between the 40 degree and the 90 degree angle, and that's this side, which is 10. And then I could cross multiply, and I get 120 equals 8x. So x is 120 divided by 8. I can't do that in my head. Yes, I can. It's 1 something. 15? Is it 15? It is. It's 15, isn't it? Okay? And then you could find y. So which side does y go with over here? This side, right? So we don't know this side. How can I find this side? Since it's a right triangle.
Pythagorean theorem.
Pythagorean theorem. And if you did that comes out to be ugly. I'm not even going to find y because does it come out to be ugly? If this is 15, we could do Pythagorean theorem. We could just find y by doing the Pythagorean theorem. You don't even have to do that, right? So you could go y squared plus 10 squared equals 15 squared. 115, whatever that turns out to be. Okay? Is that hard? So you should have C93 written down, which says if two angles of one triangle are congruent to two angles of another, then the triangles are similar. Okay? So you should know that C93. I don't have to write that down because it's on your conjecture sheet. Okay? Next one. C94 says, conjecture C94 says, if C94 says if three sides of one triangle are proportional to three sides of another, then triangles are similar. Okay? And I should have just called up the conjectures and done it that way. But so what this means, so for example, so you have one triangle over here. Here's my triangle. Here's a triangle. Did that go? Go. Look at that. That's good. So this is 5, 4, 8. And then I have another triangle. That's not the one I want. Don't write down those numbers. I wanted to draw this, even though it doesn't look like it. 3, 5, 7. And then I'm going to have another triangle. And I'm going to guess another triangle, and I'm going to call those sides. And I don't know if this is a right triangle. So, look at that. It works every time. 6. They didn't have all these tools when I was a kid. 6, 10, and 14. Are these triangles similar? Hello?
Yeah.
Yes, because 7 times 2 gives you 14. 3 times 2 gives you 6. And 5 times 10, 5 times 2 gives you 10. So yes, they're proportional. Okay? And so that's all you're going to be doing, except I want to get to the last problem, which can get kind of tricky. And then we also have C94. Let's see if I can find C94 on your conjecture sheet. Can I hide this? What happens if I hide this? What if I go in here? I don't need this anymore. Do I do? I don't need that. Do you want to close the tabs? Close all tabs. Uh-oh. We're still good. It's still there. Okay? Wait. I want to close this. I want to go to here. I want to go to here. Open Dropbox. This is where I keep everything. Geometry Advanced. I want to go into chapter 11. Where's my conjectures? I don't know where the conjectures are. Oh well. But never mind. So going back to new sheets, okay? Conjecture C94 says, what does it say? If three sides, I'm not going to write it down. If three sides of one triangle, no, that's C95, sorry. C95 says, if three sides, we just did, C93 was the one on angle, right?
Yeah.
C93 is the one side, right? C95 is side, angle, side, except this deals with proportionality. So it says if two sides of one triangle are proportional to two sides of another, and the included angle is congruent, then these triangles are similar. For instance, say I'm going to try to not make a triangle that looks exactly the same as all those other ones. Okay? There's more. Okay? And here's another triangle. That kind of looks like this in this case. So, say you know that this side is 8, and this side is 12, and this side is 6, and this side is 9. proportional?
Yep.
8 is to 12, as 6 is to 9, right? It's like 1.5 times as big, right? And the included angle is congruent. So this angle cannot be down here. It has to be in between the two triangles, okay? So similar, and you say yes, okay? So that's all that is, okay? Because 8 is to 12, as 6 is to 9, and the angle in between them is the same. Now, some applications of this deals with, so you're going to see some problems in your homework that could be a little bit tricky because you have to mess with these triangles, and I'm going to try to draw a right triangle as best as I can. A big right triangle, kind of like this. Is that going to make a triangle? Come on! Gosh dang
I
it.
don't think you were on that tool.
Oh! Let's undo that. I didn't use a tool. I gotta use a tool. Thank you. So go like this, go like this, go like this. And I'm gonna make this angle up here. Has to be a right angle. Okay? And then I'm gonna draw a line, no Yanni, okay? A dotted line. And I'm gonna draw it down like this. And I'm gonna make this a height of this triangle. In other words, this is perpendicular. Okay? All right, and I'm going to give some labels here. A, B, C, and D. Now, this big triangle, this triangle, and this triangle are all, guess what? Similar. Do you know why?
No.
I'm going to show you why. Okay? Because so this angle here is in both this triangle here, and it's also in this triangle here.
Is that supposed to be an
Right?
equilateral
No, not necessarily an equilateral triangle. So this little angle here is also in this big triangle. Does both this triangle and this triangle have a right angle?
Yeah.
Yes, this has a right angle here, right? And this one has this right angle right here, right? So that means that triangle, and you kind of have to match up. Triangle ABD is similar to triangle ABD is similar to triangle A what?
BC.
A, not B, because it has to go to corresponding parts, right? ABD, so the last angle is the right angle. So what would you call this one? A what?
AC.
ACB. Do you see that? Because this is the right angle in ACB. And this A obviously has to be the same angle in both triangles. Okay? Now this has to be congruent to or similar to, well, ACD, I'm saying is going to be similar to this. Well, C has to go in the middle in both of those, right? Because C has to be the same. Okay? So I'm going to put C, I'm talking about this triangle right here. Okay? Now, which angle, which is ACD? ACD.
Well, AC.
AC, whoops, that's wrong.
It's a B.
That should be a B, right?
Yeah.
Sorry. ACB, okay? Is similar, so in this triangle, is this the small angle or the big angle? ACB. So what goes here?
B.
Very good. B, C, D. Okay? So if you draw a picture like this, these three overlapping triangles are congruent, and then what they're going to give you is they're going to give you a problem like this. X equals 6 and y equals 4 over here, and they're going to tell you to find the height of that triangle. Okay? tell me how to do this? Set up the proportion for me.
Okay.
I figure you know how to do it since you're turning around backwards and talking while
Yeah,
I'm
I've
teaching.
almost got it.
Okay. Let's look at it this way. Let's H. So it's a little tricky, right? Let's look at this. We'll call this triangle 1, and I'll call this triangle 2. Okay. So H is to. If I'm looking at triangle 1, this is the short leg of this triangle, and this is the long leg, and this is the hypotenuse, right? So H is to 6, and if I look at this triangle, which is the long leg of this triangle right here?
BD.
Is it H or BD, right? So short leg is to long leg. As short leg, what's the short leg of this triangle?
DC.
DC. As 4 is to, as short leg is to H. Okay? And so you get H squared equals 24? 24. So H is going to be the square root of 24. I should have called this side 9 that way. So this is kind of tricky, right? Because there's a whole bunch of overlapping triangles. What you might want to do when you have this kind of problem is, split apart the triangles. So I want to put one triangle and call this triangle A, B, D. Okay? And then you could say, I know this side is 6, this side is H, this side I don't know. And then you could draw a triangle A, C, B, so that the things line up. Okay, so that's not right. And I want to draw this triangle right here as ACB, but I would do it so this would be AC, not proportional, and D, and so on. So you want to line these things up, ACB, I'm sorry. Anyway, but what you might want to do for a problem like this is separate out your 3 similar triangles, and then you can figure out which side goes with which side. You're going to have one like this on a quiz, so you should know how to do that. So they might say this is like 8, and they say, okay, what's this side over there? Something like that.
That's hard.
And then, yeah, so you'd have to say, well, this is the hypotenuse of this triangle. This is the hypotenuse of this triangle. So you could say x is to 8 as h, which is the long leg of this triangle, is to 6, which is the long leg of this triangle. See, so you have to kind of figure out which pieces match up with which. And this, by the way, is how you go about proving algebraically the Pythagorean theorem, because you use similar triangles, and I think I'll do that later on next week. Okay, I think we're done. Except I have to tell you what your homework is. Your homework is,
Did you check our homework?
I will, homework, college day, page 574.
Is that this semester?